Okay, so now I want to talk about finding the domain of a square root function. So remember that the domain is all the possible inputs, and typically that would be all real numbers unless we run into some sort of a problem. So one problem we've talked about is running into a problem where we're dividing by 0. In this case, I want to talk about the problem of taking the square root of a negative number. So we know that in the real number system, we can't take the square root of a negative number. So we have to keep the domain of a square root function so that there's never a negative number under the square root. So sometimes we can do this by looking, and sometimes we might need to apply a little bit more math to figure out what the domain should be. So let's take this first example right here. F of x equals the square root of x plus 2. So if we have the square root of x plus 2, I want to make sure that this number under the square root is never negative. So if x is 0, that's okay because it's the square root of 2. If x is negative 1, that's okay because it's the square root of 1. Negative 1 plus 2 is just 1. So if we have f of negative 1, that works because we have the square root of negative 1 plus 2. So that would be the square root of 1. That works. But what if we had f of, let's just do negative 2? Okay, so then we have negative 2 plus 2. So this is the square root of 0. The question is, can you take the square root of 0? The answer actually is yes. The square root of 0 is 0. So that's okay. But if we get any lower than that, even like f of negative 2.1 or something, we're going to get negative 2.1 plus 2, which is the square root of negative 0.1, which is not okay. So we can't go any lower than negative 2. So our domain in this case is everything from negative 2, and we're going to include negative 2 in that, all the way up through infinity. So we can have anything from negative 2 all the way up through infinity, but we can't have anything less than negative 2. Anything less than negative 2 is going to give us a negative under the square root. So that one we can do kind of just by thinking it through, but this one is going to be a little bit more tricky. So we can actually use an inequality to help us. So if we know that we want to keep everything under the square root greater than 0, we can just write greater than or equal to 0, I should say. We can just write that as an inequality. So we can say, okay, look, I know that for this to work, the square root has to be at least 0, greater than or equal to 0. So the stuff under the square root's got to be greater than or equal to 0. So then I would say, okay, 3x minus 4 needs to be greater than or equal to 0. Okay, so now if 3x minus 4 is greater than or equal to 0, I need to figure out what does that mean for x. So now I can just solve this. So I'm going to add 4 to both sides, and I get 3x is greater than or equal to 4. Divide both sides by 3. So x is, and I don't have to worry about flipping this because I'm dividing by a positive number. So I'm getting x is greater than or equal to 4/3, or that would be from 4, the domain would be from 4/3, including 4/3, right? Because 4/3 works. If we put in 4/3, we're going to get 0. But 4/3 all the way up through infinity. So this is how we figure out, if you can't figure it out just by looking like we did in this one, you can figure it out by writing an inequality and solving that inequality. And the way to write the inequality is to say, okay, the stuff under the square root has to be greater than or equal to 0. Write that down. The stuff under the square root, greater than or equal to 0. Solve it, and once you solve it, that will tell you what your domain needs to be, because you already sort of told your inequality what it needed to be. So once you solve that, that's going to tell you what x needs to be in order for the stuff under the square root to be greater than or equal to 0. And that's how you find the domain of a square root function.